So how are people doing today? I hope well. So we're finishing up. Not a whole lot left to say. Again, I guess there's only one major administrative announcement for this week. Just be aware that the final exam will take place next week. And there'll be a final exam period, like it says in the schedule for the course. I'll open the exam up on Monday morning at 8 a.m. Monday the 26th, and then it will end, the exam period ends late Thursday afternoon on the 29th. 5 p.m. I believe is what it will be set for. After that, after the 29th, I'll have the final grades in for the course within probably a couple of days. So I'm going to finish up grading everything, I think, sometime between tomorrow, Friday, and over the weekend. So you just want to you want to look at Blackboard to make sure everything's in its place, make sure everything looks reasonable. If you think that you turned something in, but it looks like there's a 0 grade, be aware that you should look into that. And if you think there's some sort of error, some sort of thing that you did turn in but didn't get credit for, let me know. But you do want to be able to get an accounting of that by at least May 2nd or 3rd, or probably 2nd, because I have to turn in the grades by that point. So maybe take a look at it on Monday or over the weekend. Some time frame like that might be okay. I don't think that anything I'm grading right now will significantly affect the grades one way or the other. So, but we do want to be complete. So the weighted total on Blackboard is kind of what the grades look like right now. So, it kind of gives you an accounting of where you are. I'm fairly happy with the way people have performed in the course. So, for people that are sort of following the conversation or completing the work, for the final, I don't think that there's too much to worry about. If you have particular questions about your grade, what the number that you see on Blackboard might convert into at this time, simply send me an email and I can respond to that, give you an answer, at least give you a range of possible answers, modulo the result on the final. So that's kind of where we are right now. A couple of people had questions about the form the final would take. I think as a group, we decided to not have the save for later option. The price you pay for that is that you have to complete the final in one sitting, but I think it's probably true that most people do that anyway. So probably not such a big deal. It looks like there is the option to sort of, for you to reconnect if the software detects that your attempt on the exam is interrupted. So I'll go ahead and select that option. That way, you're not having to email me if there's an internet problem, which, is pretty common. And if there are any, major technical obstacles or issues, you of course want to let me know. My advice on these things is, you can take the exam anytime during that exam period. You probably are taking other exams, but you just want to take some time, set aside some time during that week, finish the test when you feel like you need to. The exam will be 15 questions long. So I would estimate that if you give yourself 2.5 hours, that's probably plenty of time to complete the exam. Like we talked about before, probably somewhere between a third to a half of the questions will be from chapter 17 through 21. That's the material that we've covered more recently. I guess I should also say that I count inference for proportions in chapter 16 among those questions. I don't remember on the second exam that there was anything involving like a confidence interval for single proportions. There'll almost certainly be something like that on the final. So we've talked, I think, a little bit about what you should expect in some abstract sense. We can view the next couple of days as period of time we can take today and Monday of next week as a period of time that we can take, to make a lot of these sort of general discussions more concrete. There are a couple of things that I feel like I need to talk about. Yes, Colton.
Yeah, I was just gonna double check. Will we have access to StatCrunch calculators, things like t-tests, etc., if we need it? But if we don't need it, it doesn't matter anyway.
Yeah, you have access to everything. There's no restricted access to anything on the test.
So I think notes and
use them.
the like.
Yeah, book notes, use those things. You have access to all that stuff. So it's, that's okay. Like anything that we've talked about in class, any classroom resources are fine for the test. Where you should draw the line is, I guess I would say that there are places where you should draw the line. One place where the line should be drawn is when you're taking an open book test like this. You shouldn't consult, if you're familiar with the resources, you shouldn't consult resources like Chegg or anything like that, or like type questions in and like get people to answer. I mean, people don't really do that often, but that's kind of where the line would be drawn. Otherwise, I think everything's okay. Basically, if you have questions about what particular things are being asked about on the final, you can always go back and consult the text to get some idea. There's some examples in the text which are often helpful. Can people hear me?
You broke up a little, but we can hear you now.
Okay. So, with a lot of these things, I think just, there are certain things which are out of bounds, like asking people to do the question for you, of course, is out of bounds, but I'm sure people know that. With a lot of these other things, anything's okay that we've done in class. So if you have access to things that you've done, like reading assignments, written assignments, the book, questions that you might have done before, all that stuff's fine. Feel free to use it. StatCrunch, of course, will be available for your use. You can either use them. So I think can people hear me now?
You're very choppy, but yeah.
Yeah, my internet connection is messed up for some reason, so it's possible I may have to leave this room and go somewhere else in just a moment. So sorry about that. It seems to vary a bit. So now I think I reconnected. Everything's okay. So I can't remember exactly where I was. Right. So stuff that you would normally use in class, feel free to use on the test. Feel free to use in the final. So if you use resources on the first couple of exams to sort of finish the test, everything that you use on the first couple of exams is fine for the final. Does that make sense?
Can you say that one more time? You just cut out a bit. Thank you.
Yeah. Anything that you have used previously in the course for tests or homework or whatnot is okay to use, or I guess anything that you would have used for the 2 exams that you took previously is fine to use on the final. Okay. So, for people that are in the course that are progressing along, I guess just kind of keep doing what you're doing. I don't see, if you've been a part of the conversation, you're turning things in. With these final exams, they tend not, when I write them, I tend not to want to have them be too, I don't want to consume people with the minutia. I mean, I want to be able to ask the big questions which we have addressed during the course of the semester. So, hopefully, if you've done well on the exams, you're following the conversation, you're not going to be too mystified. There are a couple of things that I feel like I should talk about. I mentioned them, I think, last time. I guess, and people requested some description of StatCrunch, resources there that you can use. One thing that I would say is people have asked a couple of questions about reviewing old homework assignments. So I feel I need to. Talk about how you access those. So on Blackboard, and so in order to do that, I'll sort of step you through the process and you can see if this works for you. And if not, let me know. So this is the Blackboard site for the course. This is, of course, my view of it. Your view will look a little bit different, but what we have in common is this content module right here. It says link to text and course home. If you open up that content module, which hopefully will open shortly. Here, let me try again. Sorry. What is going on? So can people, I'm sorry about all the interruptions. Can people hear me now?
Yeah, we can hear you now.
It's strange.
Yeah, we can. It's just inconsistent.
Yeah, it's weird that this is is when this is going on. So I may move to another room at some point, but if it happens again, if there's an issue with it, I think I will. So let's see. So when you're thinking about okay. So when you're thinking about trying to get access to some of the course materials, the relevant content module is right here. It's linked to text and course home. So if you open that up, hopefully it opens, you'll see a couple of links. One of those is to the text. So if you click on that link, it will take you to the book itself. Another is to the course home right here. So I'll click on the link to the course home. What you should see is some version of a page that looks like this. Could be that you've already clicked this, do not show this message again, but I myself have not done that. So when I hit launch, it will take me to my stat lab. It will take you to a course page, or should. So what I will need to do right now is switch to the student view, which I think is what you generally see. So let me do that right here. So for most people that enter my stat lab through the Blackboard link, they see an image which looks a bit like this. So you can see that it has a calendar, has some material like a check mark where I think something was due, and some other items as well. So when you're trying to, this is what people see. So if you're trying to get to the results page, when you go to Gradebook, you'll see something which I think should eventually show up. All right. I'm gonna try to move to another room. Maybe that will be better. But hopefully in front of you, you see the gradebook. So what you should see looks a bit like this. It is a, it's sort of an account of where, some unweighted version of your grade, where the unweighted version of the grade is displayed. So if you want to sort of see the results on previous assignments, and understand kind of how you did on those and retry these things, you can do the following. Instead of looking at past month, look at entire course to date.
Your screen isn't shared anymore,
Okay,
so we
sorry,
can't.
let me do that. All right, how about now? People can see it. So is that all right?
Yeah.
Okay. So this is the results page, and so this is what you want if you want to access old exams or homework. From your point of view on the student view, if you access the course homepage from Blackboard, you should see the gradebook option on the left-hand navigation. So hopefully you do. And I haven't really done many of the assignments in this particular version of the course, so you kind of see what I did right here. If you wanted to actually see what the assignments look like, so to practice more, you just hit review, and it will take you to the assignment. You can review the homework by selecting individual questions. So suppose that you really wanted to do question 6 again. It'll give you some warning telling you that the work that you're going to do is not going to change the score. You can continue to review the homework, and if you do, you'll be taken to the problem and you can work on it here, provide an answer, and that's how you see it. I think you can do this also for the exams. So you might want to try that, see if it works for you, and see and let me know if it doesn't. So does this make sense? All right. So try that, see if it works. If you want to go back and look at the old assignments to kind of see, to look at the individual questions, to rework those, that's how you do it. Another thing that people wanted, people talked about this a bit yesterday, was sort of a description of what, or how, I guess, how you would use StatCrunch to do certain things. So I'll try to write that down, or at least write down some things which appear fairly frequently. So I don't need this page anymore, but instead I'll use this. So if you're talking about using StatCrunch, and I can write some more stuff down, I think on Monday, which is in a similar vein. It's, for statistical tests or for inference, we're really only looking at around five different things which are sort of content-wise not the same. So and those 5 things basically break down into 2 different larger subcategories. So for us, we could be interested in proportions, or we could be interested in means. For proportions, we can be interested in one sample or 2 sample. For means, we could be interested in 1 sample, 2 independent samples, or paired data. So StatCrunch has a way of coming up with intervals, and it has the capability of running significance tests in all of these cases. So let me just sort of try to write down a path on this set of notes in each case. So maybe this page, we'll sort of think about proportions first, and I'll sort of show you where this is on StatCrunch. So for one sample, the path on StatCrunch looks like stat, z-stats, and then one sample. And it's sort of at this point where you have to make a decision about whether or not you want to run a significance test, or whether or not you want to, run or develop some kind of confidence interval estimate. And for, I guess I could probably do this all in one show. So for 2 sample, it's a pretty similar path. Stat, z-stat, and then it's 2 sample. And I guess there's one more thing. There's usually a summary or with data option. Same's true here. So summary, if you played around with the written assignments that much, you probably realize there's a difference between just having a summary of the data and having the data, but it will run both. So how do you see this? So let me open. So I'll reshare the screen in just a second. When you're in StatCrunch, you should see something that looks like this. If you're fairly convinced that you want to be able to say something or infer something about either a single proportion or the difference in population proportions, go to stat, z-stat, 1 sample or 2 sample. So if you choose either 1 sample or 2 sample, we don't care too much about either power or width. We just care about running the test. So if you happen to have the data, If you click with data, there's typically some column of information that you see right here that you would select. When you're in this particular position, yes, Lily?
Why would you not do proportion stats? Like, couldn't you do proportion stats as well? Like,
Right here?
to stat proportion. Yeah,
Yeah,
you could do the same.
it is the same. Well, I guess I guess, well, wait, I guess I would say that with ZStat, well, one correction, I guess, with ZStat, actually, this is, like, you can tell there's a difference. This is means, right? I think you're actually right. When you go to proportion stats, that's actually what you want to look for. So I should correct myself, I think. Right. So the ZStat, we don't actually use that much. So thanks for that. So with StatCrunch, you're handling either data or not. It's either 1 or 2 sample. With summary, oops. It's just a summary. So you list the successes in the total number of observations. You can choose either a hypothesis test to work out, or you can use you can develop a confidence interval estimate. In either one of those cases, you're going to be able to get a result. The example that the sort of concrete example where you would have done this before, I think, is in, I can't remember the written assignment anymore, but I believe it's 6, where the fundamental question was you're trying to determine whether or not a majority of Egyptians want the military out of politics. That's sort of one of the underlying examples here. So that's how you handle both the 1 and the 2 proportion test on StatCrunch. Ultimately, the nature of the question and your own designs are, in a sense, responsible for determining whether or not you want to think about a hypothesis test or a confidence interval. For hypothesis test, notice that you can do a one-sided or two-sided test. One-sided or two-sided test, what you would prefer, depends a little bit on what the question of interest is, whether or not you want to figure out whether or not there's evidence that something is greater or less than something else, or whether or not you want to detect a difference. If you're interested in detecting a difference, it's the two-sided test that you're interested in. That's the sort of the default setting. If you want to change to a one-sided test, you would pick the direction of the inequality in the formulation of the alternative hypothesis. For confidence intervals, you would leave the method fixed. That's the default. That's what you would use. To come up with a confidence interval, you just sort of do it. And it will sort of, the process of coming up with the interval is basically automated. Same is true for 2 sample. Let's look at the summary page. Here you have 1 and 2 samples. You have successes and total number of observations within each sample. For this particular method, notice that the number of observations doesn't have to be the same for both samples. Since you're testing a difference, if we're running this hypothesis test, say right here, if we wanted to do that, again, you can pick either a two-sided test, which is the default, or you can pick a one-sided test in some direction of interest, depending on the question. On the other hand, you can come up with a confidence interval as well. That's that's ultimately guided, at least for the purposes of the final exam, that will be ultimately guided by the question. In real life, so to speak, it's ultimately guided by what it is you think you want to do with the question. So that's for proportions. There's something similar for means. So for means, you're either dealing with 1 sample or 2. For 2 sample, you're typically trying to measure something about the difference of means. So for 1 sample, you look at t-stat, and for 2 sample, you look at the same thing. Again, there's a choice you make about whether or not you have a summary or with the data itself. And that, of course, depends on what exactly it is that you have. Once you've made that choice, based on what it is that you actually have in hand, then you're ultimately confronted by a decision about whether or not you want to run a hypothesis test or whether or not you want to come up with an interval estimate. So to see how that looks on StatCrunch, go here. There's one more thing, right? So you have one sample with summary. If you have a summary in hand, you already have the sample mean, the sample standard deviation, the sample size. So you simply enter it there. You think about whether or not you want to run a two-sided test, which is the default, or whether or not you want to run a one-sided test in whichever direction, based on the nature of the question. On the other hand, you can compute a confidence interval as well. And the same is true for the two independent samples. One last thing there, when you're talking about t-stat, you can also run a so-called paired t-test. That was the last thing we talked about if the data were paired. The prototype example there is the Jocko's Garage problem. I think it's in reading assignment 21. With paired data, the samples will appear in a couple of different columns. Notice that for paired data, there's no summary option, because what StatCrunch has to do is it actually has to subtract sample 2 from sample 1 in the order in which the entries appear in the columns. And so that's what it will do. Again, you can run a hypothesis test where you're looking at the mean, you're trying to say something about the mean of the differences. The default setting is you're looking at a two-sided test, but you can always choose a one-sided test based on whether or not you think that's appropriate. When you formulate the alternative, on the other hand, you can compute a confidence interval. Sometimes that's also useful. One more thing about the paired data t-test. The truth of the matter is, when you're looking at paired data, what the software is hiding from you is that StatCrunch subtracts the entries, then looks at essentially the mean of the differences. If you run a one sample t-test on the differences, the results should be identical to looking at the paired data. So it has the extra option of doing it, basically, I think, because it's sort of helpful to remember, or it's helpful to not remember that sometimes that those things are the same thing. You don't really have to have the extra column if you have the two columns of data. So you might want to go back and remember how the Jocko's Garage problem actually looked to sort of see an application of that. So probably should write that down right here. So for paired data, again, you can find that under t-stat, paired data, etc. So you want to pick, whatever is appropriate to the problem. So all of that said, does anyone have any questions so far about this? So that's how you would use StatCrunch, I think, in order to solve problems that we've sort of thought about recently. Other problems that you would use StatCrunch to solve, if you want to sort of have it generate a histogram or box plots, come up with a linear regression, it can also do all of those things. And you will you will probably see a regression problem on this exam. We'll probably get around to talking about an actual example of such a thing, I think, on Monday. But for that, the written assignment associated to the voting question in the 2000 election might be appropriate to review. There also is homework on regression. Yes, Lily.
So just a question about that. For linear regression, are you talking about like the linear regression that we studied at the beginning of the semester, or like the stuff that we studied most recently? Because didn't you say that wasn't going to be on the exam?
It's the stuff at the beginning is what I'm talking about, not the stuff at the end.
Oh, okay,
So
fantastic.
The stuff most recently is not going to be on the test, as you say, but be aware that the stuff at the end, if you take a subsequent course, or if you read papers where certain language is used, when people talk about a statistically significant relationship between numerical variables, what they're talking about is a situation where they have essentially some kind of regression model, but if you're dealing with simple linear regression, then what you're saying is that the coefficient of the x, so to speak, is significantly different from 0. In other words, you've estimated the coefficient, you have a confidence interval estimate, and that interval for the coefficient, and that interval doesn't include 0. StatCrunch will do that too, but that won't be on the test. So when you're thinking about regression, you go back and look at the stuff I think that we talked about maybe in week 3, where you're basically just trying to come up with a linear model which explains the relationship or tries to explain the relationship between a couple of variables. You know, and you're thinking about what that might mean. So there's no inference involved with what I have in mind for regression. So you don't have to estimate anything with regression coefficients. It probably is worthwhile to go back and think about where you can find that information on StatCrunch. So that's right here in regression. Simple linear regression is the one that we talked about in class. I think the trickiest part here is simply to try to remember or to try to straighten out what should be X and what should be Y in your model. So, you know, you usually call X the independent variable, Y the dependent variable. The context of whatever it is that you're studying will probably dictate which you choose for which. There might be a natural choice. On the other hand, because you have X and Y and you're sort of conceptualizing them as Y varying with X, it's very difficult to get the concept of causation out of your mind, but probably important to remember that's not quite what regression is saying. A few other things that StatCrunch will do that are some items that are worthwhile to evaluate. You generally want a fitted line plot. What that does on StatCrunch is it will produce a scatter plot together with the line of best fit. There are other things which are kind of nice to see. So you can have well, we don't have any data, so it won't really do anything, but sometimes you want to understand how the histogram of residuals looks. So we did talk about that a little earlier. I don't know if I'm going to explicitly ask about that on the final, but you're hoping that the residuals are normally distributed, that the histogram looks approximately normal. You can also look at the QQ plot to think about that. Residuals versus X values tends to test for either heteroskedasticity or homoskedasticity, whether or not the variability of the residuals varies with X. The predicted values versus the residuals, that tends to tell you a little bit about whether or not there's a dependency. Earlier in the text, the author was a lot less concerned about all this stuff than later. So, you know, it's nice to kind of know the meaning of what those displays are telling you. In subsequent courses, you actually, you know, maybe more formalize the intuition that the displays of data are telling you. You can also sort of save the residuals in a column. It will do that. But I guess the point is that's where you find all this information. So at the minimum, I think for regression, I think it's important to understand what the regression model looks like. If you know that it's linear, you have to know, and I think it's probably important to know the meaning of the coefficient of X. That's the one of the two coefficients, the slope and the intercept. It's the slope that matters the most to us. From a practical point of view, the intercept plays a much less important role, because it's usually the case that a value of X equal to 0 is outside the data range in most reasonable examples. So, you know, just be aware that that's there. Regression is important. I feel like I should put it on the test. It's not the conversation we had, I guess it was on Monday, where you're sort of doing model selection or you're thinking about multiple regression. All that stuff is not for this course. It's more for a future course that you might take. For this course, you know, it's the earlier stuff where the author's less concerned about a statistically significant relationship between two variables. You know, I think the author hints at the possibility of such a thing, but, you know, never really formalizes that in the early chapters. You know, and so that's kind of where we're at. So with the statistical tests and for linear regression, you can kind of find that all here under stat. Other procedural things that are sort of nice to see. You can also come up or use StatCrunch to come up with summary stats. You have column information. If you've got two variables, you can come up with correlation. You can talk about a covariance matrix, which we didn't really, or covariance, which we discussed very briefly. But that's all there as well. I don't know that there's too much, you know, that you can use. Well, I mean, I guess you can talk about contingency tables as well. You know, we'll build that. You can run a chi-square test. You know, there's lots there that you're probably not going to have to use. But StatCrunch is nice. It's a software which, you know, at least in the minimal sense for what we did in class, you know, hopefully you're familiar enough at this point with how to find what you need in order to get it to do what you want it to do. One thing that I would add is that for future classes that you might take, you need to realize that StatCrunch is available as long, I mean, at least we pay for a site license. So you're actually always able to access it if you need it. In other classes that you might take that sort of depend on Stat 202 in some way, there's usually some somewhat more specialized statistical software that you might use. But you can always use this as well if you want to confirm results that you're getting in the other class. It's free, your access to it doesn't end with the course. So that's kind of where things are with StatCrunch. I don't know, I guess I can entertain some questions. Does anyone have any questions right now about it? I think on the homework or exam, when you have data sets, you typically click on something and it sort of loads the data into StatCrunch and then you do the analysis. But I think that's, so you're not really having to load data in like via Excel spreadsheets or anything like that. So any questions that people have?
Could you just one more time say like what time the exam goes live and then when it's due? I just didn't get to write it down the first time, sorry.
Yeah. So, I mean, I will open the exam up at 8 a.m. on Monday, the 26th. I don't actually recommend, I mean, unless you're extremely, I mean, people can do whatever they want. I mean, you can do whatever you want as long as the exam's open, but 26 is actually the last day of class. You can take the exam that morning if you want to. I'm fine with that. I mean, it's open, but it'll open at 8 a.m. on the 26th of April, and it closes on the 29th of April at 5 p.m. The scheduled time for the final exam, if we were taking a final in class, so to speak, if it made sense to do that on Zoom, I think was on Thursday. So that's kind of why it kind of motivates, stopping the final on Thursday afternoon. And, the grades will report to Blackboard, and I intend to use, some version of the weighted total to convert, your numerical score into a grade. And that's sort of those procedural details if you want to know about them. I guess those are the procedural details of what will happen over the next week. Does that make sense?
Yeah, thank you. And then I just have one, I guess, like follow-up question. Is the final going to be like the other two tests have been on StatCrunch, or not StatCrunch, I guess my Stat Lab, or is it going to be like a PDF that you send out and then we like fill in? Kind of
It'll be on my Stat Lab, so it will be very similar to the previous two exams. So you'll just go there. There'll be 15 questions. You'll sort of answer them there. So it will be like what you've done before, with the single, I guess the single exception. The expectation on the final is that you take it in one sitting rather than there being a save for later option.
Okay, cool. Thank you.
Mm-hmm. So anyone have any other questions that they might want to know or that are of that nature? So I'm gonna try to go back to the room where I was at before. Maybe the internet's working a bit better. If not, I may come back here. While I'm changing rooms again, it would be good, I think, to open the textbook to kind of see. I think I have in mind for the remaining few minutes just to kind of work on problems which kind of come from the book. The text, has some good problems. I think today we'll focus at least on some of the chapter exercises, talk a little about those, but I have some in mind. So let's, so I'll go to Blackboard, I'll go to the text. At least I think I'll do that. So the link to the text is right here. You may have other links to the text that you've used as well. So this should take us, directly to sort of the welcome page for the book. So it's will appear on the screen in just a moment. Okay. I mean, this is chapter 1. I don't really have in mind to do any problems from chapter 1 today. I do have in mind maybe to start with chapter 17, a few of the chapter exercises there. I think we'll handle this, in the way that we've handled this sort of situation in the past. So confidence intervals for means, that's maybe what we should do. So that's exercises. Chapter exercise 23, I think, is the one that that we might talk about initially. So let me find that right here in the book. Let's see, I think one more page. So what I have in mind right here for the first problem is just this discussion of pulse rates. This involves inference from means. So problem 23 on page 530. What I'll do right now is I'll break people into groups, take about 5 minutes to consider the questions. So there's a description of, there's a description of a problem, a description of a confidence interval, and, then there's a question about what is it that you're actually looking at, what's the margin of error, and what happens if you change the confidence level in this situation. So 23 might be a decent problem to look at to start. Shouldn't take too long to answer, maybe about 5 minutes. Let me break people up into groups, so you can have a chance to sort of think about it. I'll create the groups. Right now it's about 1:38. Let's meet again at about 1:45, and we'll entertain sort of a discussion and write a few things down about this problem. So now the groups, you should have your invitation to the group, and I'll see you in a few minutes. So welcome back. So when we're thinking about a problem like this, the one reason why I brought it up, one reason why I think it's reasonable to sort of talk about it a little bit, statistical inference from the point of view of confidence interval construction, that sort of subtopic of inference. I do think it's important for people to have a good understanding of this, to take it away from the course. You'll see it again if you take courses on which that depend in some way about 202. So I do kind of want to at least, convince myself that we've talked about it enough. So when you're talking about 23, you can read the problem. It doesn't really involve you doing anything. You don't have the data. You're not using StatCrunch to come up with an interval. It's largely about interpretation. And from a practical point of view, in future courses, or if you happen to read a paper in which these sorts of techniques make an appearance, this is usually the situation that you find yourself in. You have some discussion of a problem of interest, and then someone reports some kind of estimate of some quantity that they think that either you or they want to know about. So in this example, you have a medical researcher. You measured the pulse rates of a sample of randomly selected adults, and you find that a confidence interval looks like this right here. When you see confidence intervals that have this appearance, what you're looking at over here, that's 70.888 and some change. This is the lower confidence limit. The 74.497 and some change, that's the upper confidence limit. If you're trying to explain what the software output means, for a problem like this, for a problem like chapter exercise 23, you can interpret question A to be asking, or you can think about question A being as asking, what does it mean? Or how do you interpret, what does this confidence interval mean? So, one way of answering that question is something like this. We are 95% confident that the value of the true parameter lies in between, and you would report the lower and the upper numbers. So that's technically true, and a lot of people write that. I notice on the written assignments this phrasing comes up. You should remember the phrasing. It's important to remember what the phrasing is. But an interesting question is, if you look at this for a minute, does this mean that mu has 95% probability of being in the interval? And so, are these statements equivalent? I think should be something that students should at least think about before they exit the course. In the world of basic statistics, when you're thinking about the course as an entry point into interval estimation,
well, we should.
Hello. So if you're thinking about that versus that, one thing that I would say is that there's a distinction between these two different statements. The one that's correct is this one. This is not the one you want. So the parameter is either within the interval or it isn't. A parameter is a number. It's an unknown number. It's not associated to any probability distribution. And so making probabilistic statements about a thing like mu really can't be done in the context of this type of approach. So we're assuming that mu is an unknown number, and we want to say something about it, and we're providing a range of numbers which represent a plausible estimate of what mu could be. Either mu lies within the interval or it does not lie within the interval. One of those two things is true. And the truth of the matter is you'll never really know for sure whether or not it is in the interval. All a confidence interval really is, in a sense, is a set of values that a reasonable person might believe, contain the parameter. It doesn't necessarily follow that the parameter is in there, but it's a range of reasonable values. So that's an important distinction to think about. I can imagine asking a question in the final which tries to draw that distinction. So be aware that that's out there. For some of the other parts of the question, what's the margin of error? There was a problem that's a bit like this that you saw before. So I guess what I would say for part B, just remember that our interval, our formula for the interval, if I sort of rewrite this using interval notation, the formula for the interval that we have, since we're dealing with means, always looks like this. So it's always the value of the point estimate minus the margin of error. That's the lower confidence limit. And the upper confidence limit is the point estimate, X bar in this case, plus the margin of error. So that's the formula, in a sense, for the confidence intervals that we're considering. This guy's the lower limit. This guy's the upper limit. So when you're talking about computing a margin of error, how would you do it? Maybe visually, a confidence interval looks like this. Here's the lower limit. Here's the upper limit. The point estimate is right in the middle. In this example, we know the distance from the lower limit to the upper limit. And because of that fact, we would interpret the margin of error as being half that distance. So the margin of error in this case, is basically the upper limit. So what would it be? It's it's halfway across, right? So you take the upper limit minus the lower limit divided by 2. The upper limit minus the lower limit is the whole length of the interval, but you only want half of that. That's the margin of error. So that's one thing. That's one sort of conclusion you can draw. You can see that pretty quickly in this formula without really even thinking about the visualization, because if you take this guy right here and subtract this guy right here, the algebra of the situation implies that you get 2 times the margin of error. And so just divide by 2 to get the actual margin of error. If you know the interval, as it turns out, you also know exactly what the point estimate is. It's right in the middle. So that's how you handle something like B. I think B is mostly about just kind of remembering what the confidence interval looks like, what the formula is. When you're thinking about part C, I think C, again, I think C is an important question from the point of view of, just trying to understand what what it is, what the actual formula for the margin of error is in, in cases that, that are important to us. So one thing that I would say, so I'll write this down in just a second, but if you're thinking about this question, well, okay, look, you've got a 95% confidence interval. If you went and computed a 99% confidence interval, would there be a difference? If so, how would that difference materialize? A confidence level is associated, all other things being equal, a confidence level is associated with the critical number, which will appear in the formula for the margin of error. So in a problem, in a problem like this, I think I hit something over here and I can't seem to access. So in a problem like this, how would you actually come up with a decision? Like, well, the decision is basically this. The larger the confidence level, the wider the confidence interval. The critical numbers are an increasing function of the confidence level. So when you're dealing with means, depending on the number of degrees of freedom, a 99% confidence interval will always be wider than a 95% confidence interval, which itself will be always wider than a 90% confidence interval. So again, I think just those basic properties about interval estimates and the content of either increasing or decreasing the confidence level and the consequences for the interval are important to remember as well, in addition to the interpretation. So with that in mind, I'd like to maybe think about the next problem. The next one I have is this question. Let's see. I guess it's this question 35. So the question 35 on page 531, this involves a little bit more work. What I think about this question is, let me go back and share the screen so you can see what I'm seeing. It's this guy right here. For this particular question, the book itself has the data set kind of embedded into it. So if you're trying to address question 35, it's easiest to do this with StatCrunch. If you actually want to find the interval, you would do that simply by clicking over that button right there in the text. The data will load into StatCrunch and you can come up with the interval estimate. I think that the most important thing about 35 is to briefly at least think about what the conditions for inference are, and to try to think about whether or not they actually apply to this case. So, I think with that in mind, it's about 1:55. This probably won't take that long to answer. Again, I'd like to give the group some time to think about part A. If you're talking about inference for means, what conditions really are in play? Do we know that they're necessarily satisfied in this case? If not, what might the points of departure from those conditions be? So take a few minutes as groups to do this. It's about 1:55. Let's meet again at about 2:01. So you should have the invitation now. I'll see you in a few minutes. So welcome back. So in considering the question, let's see. So in considering the question of interest to us, I actually managed to put this right over the questions. Let me move that down. So on 35, you have some information about flights. What's the nature of the question? What are the chances your flight will leave on time? Bureau of Transportation Statistics publishes information about this. A histogram and the summary statistics for the percentage of flights departing on time each month from January 1994 to June 2016. You sort of see right here. These things are reported, I think, as whole numbers, I think, in the histogram. So you're seeing on-time percentages. So these aren't proportions. It's ranging from about 65 to about 90. There's also the statement, there's no evidence of a trend over time. So, you're trying to think about what that might mean for the problem. So if you're thinking about something like A, you're thinking about the assumptions and conditions for inference. One thing is certainly true. you feel like the nearly normal condition for inference is basically satisfied by what you're seeing here. The sample of flights that you see is unimodal. It's not entirely normal, but you're not that troubled by it because there are evidently a huge number of flights. It's saying that n is equal to 270. That's the size of the sample in this case, easily big enough to satisfy yourself that the central limit theorem applies given the shape of the data. So, when you're thinking about the conditions for inference, the nearly normal condition appears to be okay. What you'd really worry about in this case, if you're thinking about what a non-example, something to worry about would look like, if you looked at the histogram of the sample and you saw something that was extremely skewed with a small sample size, you'd worry about things a little bit. Methods might not work. But in this case, you've got a large value for n. You've got, a very clear idea that, that the data is probably drawn from a distribution which is roughly normal. The one question that I would have about inference in this case would have to do with the randomization condition. If you're not doing an experiment, if you're just looking at information, do you think it's random? Well, okay, look, you're looking at January 1994 to June 2016. Is there anything in particular? If you're trying to make a claim about all possible flights, you only have what's going on through an interval of time. And so, do you feel like you have 270 months that you're dealing with? Do you feel like, do you feel like there's anything special about those months? And I guess the statement right here might be important to try to diffuse that fear a little bit. There's no evidence of any trend over time. You don't feel like months are related to months in any particular way when you're looking at the percentages. So, when you look at the histogram, I think this statement is meant to sort of convince you that the randomization condition is one that you shouldn't be worried about. Even so, you're not, if you're trying to make a claim for months across all, across all time, or if you're looking at percentages each month, it's hard to believe that you could say very much about like what's going on. Again, there should be a question. Maybe it's not as much of an issue as I'm making it out to be, but the randomization condition, you would probably be more comfortable if you happen to know this information for all time and you randomly chose some months out of a larger collection of months and then just saw what happened for those, rather than looking at what's going on through a particular interval of time between 1994 and June 2016. Now, so when you're talking about a 90% confidence interval for this true percentage, if you're using this as a way of estimating something like that, parts B and C are fairly straightforward to do via StatCrunch, remembering that we have the summary data right here. So you simply load the data into StatCrunch, you press that button and it will appear. And so, what are you really looking at with the data? So here you have the months. Here you have the arrivals, you have the percentages, I guess, for each month. So, you have arrival delays, on-time percentage. So what is it that we really want to know in this example? On-time departures is what's of interest. And so, you would basically use StatCrunch to try to come up with an estimate of something like that. Hang on just one second. Right, now we're back. So at this point, a 90% confidence interval in this case, you have a bunch of information that you don't need. You have the total number of flights canceled. You have the on-time percentage right here, which is the thing of interest. So you just sort of proceed as you would think. Go to stat. Should you use t-stat or z-stat? I think in this case, t-stat is the way to go. It's one sample. We even have what's going on with, we can even use with summary. We don't even need the data set itself because the summary is reported to us. So we know what the sample mean and the sample size is. Sample size is 270. The sample mean looks like it's 78.099. The sample standard deviation is 5.010. And at that point, I think everything, let's see if I can hold in my mind what these are just for a second. 78.099. sample standard deviation 5.010. You want a 90% confidence interval in this case. And so you, at that point, can compute the thing, and you get an image that looks like this. So you have a lower confidence limit on the order of about 77, upper confidence limit on the order of about 78. Notice how narrow the interval actually is. So in this case, the interval is very narrow. Sample mean is right in the middle of the two. Standard error is tiny. That's a feature of having a very, very large sample size. 270 gives you something rather narrow. So, you know, the interval isn't that large, so it's almost as though the point estimate is roughly what the interval estimate actually is. The interval is only about, you know, a little over one percentage point across. So, you know, with that in mind, let's see. You know, with that in mind, you know, you have the interval, you can talk a little bit and interpret it. You feel like a traveler is probably not going to be delayed in this particular case, but you know, chances are, you know, that, you know, but the chances aren't terrible that they're going to be delayed, because roughly, because this is saying that a plausible estimate for the percentage of flights delayed is about somewhere between 77.5 and about 78.5. So it's somewhat unlikely that you'll be delayed, but not so unlikely that, you know, you think it's something that you can't ever happen. So again, that's one sample mean. You're sort of looking at estimating a mean value. What you would expect, you know, the expected percentage of flights that get delayed is what's trying to be estimated here by looking at the monthly data. And then you can provide that information to the traveler. Does anyone have any questions about this right now? It's about 2:08. I don't think I'm going to take my chances anymore with the internet. So I guess with this in mind, you know, I think probably that's enough. We'll start on Monday with more problems. I think on Monday, we'll talk a little bit more about 17, 18, 20. I might preface my comments about the problems with maybe more direct statements about what would be reasonable for a test. I think on the questions that we've talked about so far, where you're having to interpret a confidence interval and then maybe compute one, that's totally reasonable to ask on the test, either from the point of view of testing about means or proportions. I don't know that I want to go back and do any problems with proportions. You know, that might be a bit redundant at this point, but I feel like the problems that we're asking about here are reasonable. If you're thinking about what you might expect to see on an online exam, when you're talking about the conditions for inference, these are likely to appear as, you know, sort of a set of multiple choice questions where, you know, some of the possibilities are no, the conditions aren't satisfied. Other possibilities are yes, the conditions are satisfied, and you would have to explain why. So I feel like I should be able to ask that. But that's kind of what I have in mind for one sample mean. Maybe on Monday, we'll be able to talk a little about, you know, probably won't talk a little about 18, which is significance testing, and then 20 and 21, maybe do about 3 more problems, and that probably will be enough. So that's probably enough for today.